Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about exponential and logarithm basic maths which we are going to use in cryptography. And we already know from our +1, +2 mathematics, exponential can be written as y is equal to a power x. And logarithm is exactly opposite. Logarithm is equal to x equal to log y base a. These are inverse operations. If you want to find y, a power x. If you want to find x, log y base a. These are inverse operations. Why we are stressing here is from our beginning of cryptography, whatever the mathematical functions we are using, they are inverse functions. Invertibility should be provided. That is what we have done in symmetric key cryptography. Similarly, these are inverse functions. And now in our cryptography, most of the times we are going to use y is equal to exponential modulus a power x mod m. Similarly, the invertible function is x is equal to log y base a mod m. These two are invert functions. But in cryptography, we need to understand, is there a polynomial time algorithm to find the large exponential values, a power large numbers, because we are dealing with large numbers in asymmetric key cryptography. So is there a polynomial time algorithm to find the exponential values? Similarly, is there a polynomial time for identifying the logarithm values? That is what we need to understand here. So in order to understand, yes, there is a polynomial time algorithm for finding the exponential values, but there is no polynomial time algorithm for finding the logarithm values. So the algorithm is fast exponent algorithm, which we are going to discuss here. We will discuss the example, and at the end we are going to discuss why it is provided in polynomial time. And here we are going to provide you an intuition why logarithm don't have an polynomial time algorithm. That is what we are going to give you an intuition. The detailed mathematics is there. We are not go deep into the detailed mathematics because the point we need to understand is why it is not possible to identify polynomial time algorithm. That intuition we are going to provide here. Let's try to understand it, why it is not possible. See here, logarithm means x is equal to log y base a. How we are going to identify the logarithm values? By looking at the tables, base 2, base 5, base 3. Similarly, here also we need to generate those tables. But in cryptography, we are going to use a large values, any value. Is it possible to generate all the logarithm tables for the given base? No, because we are dealing with large numbers. Finding those tables for all the bases is not possible. So that's why we are not going to, we don't have a polynomial exponential time algorithm for finding the logarithm values. We don't have a polynomial time algorithm for finding the logarithm values. We are having exponential time algorithm. Now coming to understand why fast exponent, how fast exponent works and why it is polynomial time algorithm. Now try to understand, given y is equal to 17 power 22 mod 21. See here, this is very simple number, but if you are dealing with large numbers, is it possible to find 17 power 205, 17 power 505 like that? It's very, very complex to do the calculations, but there is a fastest algorithm which we can identify exponent values in modulus in polynomial time. Let's understand this. Here we are going to identify y equal to a multiplied by y mod m, a equal to a square mod m. These two formulas we are going to use here. See, 22, 17 power 22, 22 is written in binary numbers, 1, 0, 1, 1, 0. These binary numbers write from left to right, 0, 1, 1, 0, 1. See here, initially we have to take y is equal to 1, a is equal to 17 because it is given a is equal to 17. Initially take y is equal to 1. If you are having 0, don't find y, just find a. If you are having 1, find y and find a. So 0, don't find y is equal to 1. A square mod 21, which is 16. So we found a. Similarly, next 1, y is equal to a multiplied by y. What is y here? 1 multiplied by what is a here? 16. 1 multiplied by 16 mod 21, which is 16. Similarly, a is equal to 16 square mod 21, which is 4. Again find 1, y is equal to, now y is equal to 16, a is equal to 4, 16 multiplied by 4 mod 21, which is 1. A equal to 4 square mod 21, which is 16. Similarly 0, no need to find y, just find a is equal to a square, which is 16, 16 square mod 21, which is 4. Similarly, for the last one, no need to find a, just find y is equal to 1 multiplied by 4 mod 21, which is 4. So 17 power 22 mod 21, which is the value is 4. This is how we are going to identify, this is what fast exponential algorithm means. See, if you are having a large number here, you convert it into bits. What's the biggest numbers we are taking in cryptography? In our last classes, we discussed the large numbers, which is having 1024 bits. So this algorithm executes for 1024 times. For each bit, we are going to do this calculation, which is a polynomial time algorithm. So that's why finding exponential values for large values is polynomial time algorithm, but we don't have the converse. It is exponential time algorithm, means it executes, it will never come output. So these points you need to understand in order to understand our next classes, which is asymmetric key cryptography. Hope you understand this class. If you have any questions regarding the concept, please post your questions in the comments section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.